Part 3 of the homework, we're going to explain and code a function that calculates a surface point, a distance of a radius of 0.5 from the central helix for arbitrary angle theta between n and the cross product of t multiplied by the normal vector, the tangent multiplied by the normal. And we're going to also figure out why is it necessary to use the cross product tangent multiplied by the normal vector. So multiplying the tangent by the normal vector, you get the binormal unit vector, which is b, the cross product of t and n. So the reason is important is the plane is always changing tangent to the curve. And what we're trying to do is we're trying to go back over here. I'm going to run this again. We're trying to build a wireframe around this helix, starting from 0.5, a radius of 0.5 from a point around the helical curve. So the first thing we want to do is we want to create a list. So what we're going to do is we're going to go into Google Collaboratory. What is this? Oh, yeah. Oh, this is... Oh, that's the when I was practicing. I shouldn't have looked at that. Oh, this is it. Yeah, I was practicing on that one. Okay. So what we need to do is we need to build a list. So tangent, well, not tangent. So I'm going to start right here because it's nicer. I'm going to start at theta. I'm going to define theta, set of values. It stores values in an array. Not an array, but in a list. We're gonna do it 2 rotations. So we want 2 pi, 2 gnp dot pi. We want 16 of those values, or we can say 120. So we want to define a function, and that function is the surface that will take in the time and also the theta values. So what that does is going to create a function of the surface points. Simple enough. So we're going to define some things, like we're also going to define the radius 0.5. We're going to define tangent at a point in time. We're also going to define the normal vector at a point t. We're also going to define b, which is a cross product. We're going to use gnp dot cross, and we're going to take in the values of t and n. So what that function does is just going to take the cross product of t and n. Well, and the point of it is once you take the normal and tangent, it's going to be unit vector. It's going to be tangent to the plane. So all around the points. Okay. I want to do that. So what do we need to do? We need to return something. We need to return, we want to find a curve at t. We want to also find, we want to merge the arrays. So the way we're going to merge the arrays so we're going to be able to stack on top of each other and make that coil is we're going to need to take that cross product. So we're going to find n, the normal vector times the binormal vector, and we're going to do it on the axis. And in the axis, we're going to give it a value of 1. Why are we picking the 1? Well, it's because it's going to be on the y-axis, and the y-axis is at 1. If it was x-axis, it would be 0. So simple enough. Now we're going to do the at, multiply it all. We're also going to multiply by, we're going to have the array of values. So we're going to find the radius times j and b times cosine of thetas, all the values we're going to have stored. And we're going to do that for the x and the y direction. Sine theta. How's that looking? Looks good. So now we want to define the surface. I want to give it some initial points, so we're just gonna look right now at the initial points. So let's say we didn't I'm gonna delete this. And then we're gonna run it. And then we're gonna give it initial values of 0. And we're gonna run it. Now, if you see, we got negative 16, 0, and 0. So if we go up negative 0.16, that is not going to be anywhere close to where the helix is going to be. So that's why we're trying to add the curve of the function we made up earlier, so that when we run it, and we rerun it, we get 2.83, which seems right. 2.83. You could see it'll align around the radius of the helix. Okay? So now we're going to need to make a vector. We need to vectorize this function. So we're going to make surface underscore vector. And we're going to do jnp.vectorize. So what this is going to do is going to be, it's going to create an array. Scalar. I'm thinking. So we're really just going to be creating a matrix, taking multiple matrices and creating a new matrices, so that it just all combines all together. So the way we're going to do that is we're going to contain the surface, what we defined, and we need to make a signature, and it's a scalar. So we're going to give initial values of nothing here, and then another initial value of nothing here, and then we want to give it 3. The reason why we're doing is 3 is because we want to be a matrix of x, y, and z. I mean, I feel like, wouldn't that be there? Yeah, that seems right. I always get scared when I get an error. So the surface, I'm just making sure I'm recording. So the surface, okay, we need to rename it the same thing we had before. Surface equals vector. Now we're going to call it at the time t. We're going to give it initial value from starting from 0 all the way none. And then we're going to do the same thing with data. Well, it's going to be vice versa. We're going to start it at, how did that even come there? We're going to start it at none. Then I'll do this colon. Okay, we gave all the values that we were gonna make around, that goes around to make the coil. Now, if we want to explain this better and make it better, we're gonna shape it. We're gonna do dot shape and we're gonna run it. So it's basically telling it's gonna be 100 points from n values, and then the new points around the value of t, which is 20, and then 3 is going to be for each of the 20 values. For each of the 20 values, you're going to have 3 values of coordinates, which is going to be the x, it's going to be the y, and it's going to be the z. So that's what each of those 3 things are telling you. And then from here, we're going to be able to make the coil around the helix going up in the t direction to calculate